Lesson 1F, Part 2, Solving Radical Equations with Two Radicals. So, how do we do this? Here's our steps. So, we move the radicals to the same side of the equation by using reverse BEDMAS. You move all constants to the opposite side of the equation as radicals. You add like terms on both sides of the equation. You isolate the radical by using reverse BEDMAS. You square both sides to remove the radical sign. And then you simplify and verify, meaning check to see if your solution is true or if it's an extraneous solution. Okay, so let's take a look at how this is done. So first of all, I'm going to move my 4 to the right. Okay. Now I'm going to add them to, or take my radical to the left-hand side. Now I'm at the last step where I square both sides. You're going to get x is is equal to 25. Let's check our solution. Okay, so now I'm going to take 3 and times it by the 5, the root of 25, and then subtract 4. On the right-hand side, I take 2 and subtract by the root of 25, which is 5, and then I add 1. So I'm going to get 15 subtract 4 on the left, which gives me 11, and on the right, I get 10 plus 1, which also gives me 11. So left side does equal the right side, so yes, this is a solution. Okay? Don't forget, we always have to find the restrictions on our variable. So we're just going to put our variable greater than or equal to 0, comma, XER. Okay, there's our restriction. Check your work. Now take a look at this one. It says identify extraneous roots. So first of all, does our question have an extraneous root? We're not sure. Sometimes when we got radicals on the opposite sides, we can still square both sides like this, okay? We don't always have to take our root sign to the left-hand side. In this case, it's going to work anyways. So let's just square both sides and see what happens. I'm going to get x minus 1 equals 2x plus 3. Now I'm going to subtract my 2x and take it to the left. I'm going to subtract my 3 and take him to the left. And then I add like terms. Well, on the right-hand side, that's just going to give me 0. Okay? So I'm going to end up with an x and a negative 2x give me negative 1x minus 4 equals 0. Now I just move my 4 over, so plus 4, negative 1x equals 4. Divide by the negative 1. We're going to get x equals negative 4. Okay, now let's take a look here real quick. If I did it the exact same way by taking my radical to the left, would I get x equals negative 4? Let's find out. Okay, doing it the other way. This is a hidden positive sign in front, so I'm going to subtract that whole radical. 2x plus 3. But remember, when the root sign disappears, you're going to have to put it in brackets because there's more than one thing inside under the radical there. So I'm going to have root x minus 1 subtract root 2x plus 3. All equals now 0. I'm going to square both sides now. Square that. I'm going to get x minus 1 minus 2x plus 3 equals 0. Now remember, I said that the radical being subtracted must come down in a bracket. How come? because we're subtracting it. And that means we're actually going to multiply by -1 in the bracket. It's basically going to change both those signs. So I end up with x minus 1 minus 2x minus 3 equals 0. I add those together to give me -1x minus 4 equals 0. Add my 4 to both sides. I get -1x equals 4. Divide by -1. I get x equals -4. So you get the same answer doing it both ways. Okay, let's check now and see if I have a correct solution or not. All right, let's do our check. Okay, hopefully you guys are noticing something right away here. I'm going to get root of -5 on the right-hand side. I'm going to get root -8 plus 3, which gives me root -5. Now, even though the left side does equal the right side, can we ever have a negative sign under the radical? The answer is no. So actually our solution is not a solution. It's extraneous. Okay, so it's not a solution. So x equals -4 is not a solution. Okay, how come? Because in the end, we ended up with a -5 under the radical. We ended up with a negative value at our radical. Doesn't matter that they both equaled each other. The fact is that it's a -5 under a radical. Okay, let's take a look now and see what happens on the bottom. Okay, example 4. Again, I can square both sides. So I'm going to get 2x subtract 5 equals x minus 7. Move your x to the left. I'm going to subtract my x. I'm going to get, 1x left over. I need to move my 5 to the right, so I'm going to plus 5 to both sides. So now I'm going to get 1x equals -2. So I found an answer of -2. Let's check and see if it's a proper solution. Okay, I'm going to substitute x in where it belongs. Okay, two things happened here. I ended up with a negative under both roots, and my roots are not the same. So my left side here didn't equal my right side, but as well, I ended up with a negative under the root in the end. I have a negative under my radical, and it's not allowed. Okay, so because it's not allowed, x equals -2 is not a solution. Okay, so we would say it's an extraneous solution. Extraneous solution means it doesn't work. It's not a solution. Okay, let's try the next couple. These ones are for you to practice. Push pause now and play when you're ready. Okay, you've had some time to look at this. Let's take it up together. So, square both sides. Let's see what happens. 4 equals 3x minus 1 plus 1. 5 equals 3x. Divide by your 3. X equals 5 over 3. Okay? Let's check and see if that works. Now I put my x in, 5 over 3 minus 1, and I have a 2. Now, when you put that in your calculator, you're going to take 3 times 5 divided by 3. You're going to notice your answer is 5. How come? The 3's are going to cancel. So we're going to get the root of 5 minus 1. On the right, we still have a 2. We get root 4 and 2. Root 4 becomes 2. The answer is 2. So yes, the left side does equal the right side. So yes, this is a solution. Okay? Don't forget, we do have to put the boundaries on our variable. So the boundaries on our variable here, we're going to have 3x minus 1 equals 0. Now I'm going to take my 1 to the right. Don't forget, part B, it's not equals, it's greater than or equal to 1. Plus 1 to both sides. 3x greater than or equal to 1. Divide both sides by 3. X must be greater than or equal to 1/3, comma, XER. So that's what we found for our boundary or restriction. Okay, so don't forget your boundaries. Check your work, please. Okay, take a look at C. We're going to square both sides. 5x plus 3 equals 3x plus 1. We subtract our 3x for both sides. We subtract our positive 3 to move it to the other side. Then we add like terms on both sides. So my positive 3 disappears, my 3x disappears on the right. I end up with 2x equals negative 2. Divide by our 2, I'm going to get x equals negative 1. Let's do our check and see if it works out. Times negative 1 plus 3. 3 times negative 1 plus 1. It's going to give me negative 5 plus 3, which is going to give me negative 2 underneath my root. Over here, I'm going to get negative 3 plus 1, which also gives me negative 2. They match, but there's something wrong. There's a negative under my radical, so it's not a solution. Okay, even though the right side equals the left, it's because of that negative sign under the radical. Remember, that can't happen. Okay, so let's take a look and see how you did on the next few questions. Square both sides. Oh, sorry, the root sign disappeared. What am I doing here? Okay. Negative 3x plus 7 is equal to negative 2x plus 9. Move my 2x to the left. And I'm going to move my 7 to the right. So I'm going to subtract 7 to both sides. Now I'm going to add like terms to both sides. I'm going to end up with negative 1x equaling 2. Divide by our negative 1. I'm going to get x equals negative 2. Let's see if that is a proper solution. Let's do our check. Left side, right side. So on my left side, I've got root negative 3x plus 7. Over here, I've got negative 2x plus 9. Okay, put in my x. I got a negative 2. Okay, root 13 equals root 13 in the end. So yes, left side equals the right side. So yes, it's a solution. Now last time it didn't work out that our negative number was a solution, but this time it did. How come? Well, the reason it worked out this time is because I already have a negative value in front of my x. That means that the negative answer for x is going to multiply by a negative to result in a positive answer. That's exactly what happened when I take a look. That's exactly what happened right here. Our negative times a negative gave us our positive answers under a radical. So our negative did disappear. So yes, sometimes you can have an answer that's a negative value. You just must check the solution to make sure that it does work out. Okay? Check your work, and let's see how you did on letter E. Okay, on E you had to move your 43 to the right. So we're going to plus 43 to both sides. And then you had to move your x, your root x to the left, so we're going to plus 10 root x to both sides, plus 10 root x. So on the left-hand side, I have 10 minusing 4. I'm going to get a positive 6 root x equals negative 7 plus 43 is going to give me a 36. I need to divide out 6 to both sides now. I'm going to get root x equals 6. Now I've isolated my radical. That's always your first step. You have to isolate the radical before you square both sides. The other questions I was able to square both sides first because everything was isolated. So we get x equals 36. Let's do a check. Left side, right side. Negative 4 root x minus 43, and negative 10 root x minus 7. So that's going to give me negative 4 root 36 is my x, minus the 43, minus 10, root 36, putting your 36 where x is, minus 7. So this is going to give me negative 4 times 6. Subtract 43. And on the right, I get negative 10 times 6, subtracting 7. So negative 24 minus 43 is on the left. Negative 60 subtract 7 is on the right. So I'm going to get negative 67 on the left, negative 67 on the right. Left side does equal the right side. So yes, 36 is my solution. Okay? Okay, we've got a couple problem-solving examples. Let's take a look here. How are we going to tackle one of these? So we've got our equation, d equals root 13h. So what does d equals? Well, d is the distance to the horizon, and it's in kilometers. And h is the height of meters above sea level. So it says an observation platform is to be built on a fire tower. The base of the tower is 100 meters above sea level. How high must the observer platform be? So his distance from the horizon is 50 kilometers. Okay, so let's take a look. 50 kilometers, that's our d. That's our d value. So we're going to substitute d in. So we've got 50 equals root 13h. And I need to solve for h. So on the right-hand side, my equation is isolated my variable already, my radical. So I'm just back to squaring both sides. So I'm going to square both sides, and I'm going to get 2,500 is equal to 13h. Last step, divide by the digit in front of the variable, divide by 13 to both sides. We're going to get h is equal to 192.3076, and etc. It runs on forever. So it wants us to round. We're going to round to the nearest tenth. So the height is 192.3. Oh, this one's in, oh, that's meters. We're good. Okay, so we want height. The height is in meters. Okay, final solution. And again, we have to find out what h can't be. So we have 13h greater than or equal to 0, divide by 13. H must be greater than or equal to 0, H-E-R. Okay, so don't forget, you always must do your boundaries. Okay, let's take a look. Well, first of all, what did you notice about the 100 meters above sea level? Well, first of all, that's just too much information. It doesn't matter about that number. We're not using that in our equation. The reason they did that is because they wanted to know, are you putting your 100 meters on the left, or are you going to put the 50 meters on the left? That's why they did that. They wanted to see which one you put where and on purpose, okay? So really, they were seeing if you knew to ignore the 100 meters. All right, let's look at the last question here. Our last question, again, has an equation for us already built, and it tells us that the period, P is in seconds, so the letter P is seconds, of a pendulum, so that's something that goes back and forth, is the time to complete one full swing. The period can be determined using our formula. L is the length of the pendulum that you're using in meters. How long should the pendulum be to complete a full swing in 2 seconds? Well, that 2 seconds, that goes where P is. So I'm going to have 2 equals 2 pi root L over 9.8. And we're going to solve the equation like we would normally. So I need to isolate my radical, so I'm going to divide both sides by 2 pi. That's going to give me 1 over pi equals root L over 9.8. All right, I'm back to the step where I can now square both sides. I'm going to get 1 over pi squared, 1 squared, because I can solve that. 1 times 1 is 1. But pi is a run-on decimal, so you can't actually write the digit down unless it tells you how far to round pi, and it did not tell us. So we need to keep pi as our variable there as well. We have another variable. Equals L over 9.8. Now I've got on the right-hand side, since I'm solving for L, I need to be able to get that 9.8 off the bottom. So that means I'm going to use my algebra rules, and I times both sides by 9.8, and then it'll disappear. And that means I times it to both sides. So I'm going to times the 9.8 as well. Now when I do that, the 9.8 is actually over 1 as a fraction. So you're going to times your top numbers and then the bottom numbers times. So you're actually going to get 9.8 divided by pi squared. And that's what L is equal to. So now we've solved for L. You can actually type that number in and find the decimal place for it. Round to 2 decimal places. So when we do that, we're going to get L is equal to 0.9929, and it goes on forever. We wanted 2 decimal places. So we're going to have the length of our pendulum should be 0.99 meters. Okay, so almost 1 full meter length, but not quite a meter. Okay, this concludes Solving Radical Equations, Part 2. This is the end of our unit. You should have all your practice book sections done and your unit assignment done as well.